Um, Hello once again. I made this quick video just to show the wise ass marketing genius that you don't need two page these to connect solar panels into the medium voltage lines. Yeah, one PhD for DC current and the other one for AC current. Although in Portugal you need an academic title, so and you have to be associated with an order, which it's not needed in France or Germany, although it's also EU, right? But anyway, like in the previous video, I ain't going to discuss much about cables and calculations and so on. I think you have to do that by yourself. Every project it's a project, so okay, and there's a lot of details to it. For instance, you have to for in this case, this is the high voltage cable, AC, um, not high voltage, but medium voltage. So sorry, and you have to do this correctly, so you can fit in the connector. And you have to. This is not the precise measure for. You have to research which kind of measurements you need to pull up or cut the isolation from, right? And there's also the as usual you have to calculate the you have to calculate the cable you have to calculate the cable for the current and the voltage. You have to be aware of the voltage too and the weather conditions, right? And so this case is for the voltage. The medium voltage goes from 6,000 volts to 30,000 volts. So you have to do your research and what you need for instance overshoot voltage. You have to calculate. Also, it's a bit tedious. It's a tedious work. So in these cases, you have also problem with heat dissipations, and you also have some more details about if the cable goes underground, so you have to have a thicker outer isolator. So, and this kind of details I won't mention in this video. So let's start by the transformer. It's an integrated one from SMA. Um, Now the local companies here they choose the status quo, and I chose the first one that come in the search machine. And later on, I noticed that they also have a video by YouTube. I will put the link below. So let's take a look at this. Take a look at datasheet of this power station. So it's probably a power with modulation and a transformer, and the output for the medium voltage as usual. Now we want to see here for our imaginary project here, and I want to do this quick. We have to search for certain data to feed the bureaucratic monster. Also, you have to see several things. You have to do isolation tests. You have to see the short circuit current. But we in this imaginary project we have to be practiced because it's getting late. And this video should not be too long. So we have here max input voltage from the DC side, 1000 volts, and the maximum current will be 1250 amps. So it says here 2, but it's 2 maximal, the maximal from the 2, because if you do the calculation is 1250. Yeah. So number of DC inputs doesn't matter for us at the moment, right now. this doesn't matter for us either right now at this moment. Mm, yeah, it's a lot of data. You have to choose the voltage, output voltage from the AC side. A lot of data that you have to feed the bureaucratic machine and to calculate also. Interesting is the DC connections. Ring terminal lug should be straightforward, and this AC connections from the medium voltage side is outer cone angle plug. It means it's a standard outer cone angle plug. So this is straightforward. And I'm going to also talk about the the communication here with internet, optical fiber, optical Modbus, and everything. We're just going to keep simple in the and let's go. Yeah, so this is a main view on what we should have. So we have to buy also some string monitors just to pick the arrays, pick the solar panel arrays, and connect and bundle them together just to connect to the power station. And this is the power station itself, and it's exactly what I have planned in the. Now we go yet to the string monitor. String monitor is here. So we have 1250 amps. We have to see how much the monitor, how much the strings monitor will put out. So maximal output DC rated current is 215. So you need four of those. You need four of those to distribute the DC voltage. I mean the DC power to feed the power station. And this is how this get done, right? PV models, and it's get feed into the string monitor, and afterwards yeah, gets connected. Yeah, string monitor and Sunny Central, and goes right away into the grid. So let's go to the main project. So this is the project like in the previous one. You have the solar panels with the same values, but you have to calculate just to fit in to the to the to this project. Um, the part of connecting to the grid and the the connection to the grid is not made by the it's made by the power distribution company. So um, but I will show you, since I had to study the medium voltage and low voltage procedures, because I've worked for some power delivery companies, and you can tell by the videos from the crazy power meters. They really didn't have the fault, but anyway, it turns out they didn't like cats. So no matter where you go, you go to the entrepreneurs side, they don't like cats. You go to the syndicates, you can call it union, they don't like cats either. So let's move on. This is just what we need, just because I mean you have protective switches on the transformer side, and here you have only fuses. This is not a switch. This is only the fuse needed by the to protect the medium voltage cable, right? So it's connected to the grid. This goes down, and you have to make some compartment underground to make it easy and for the guys to pass the cable, right? Uh, yeah, and for the guys to have access to pass the cable, and everything here for this for 35 square millimeters, it's the law. Yeah, they make this law, and this 35 square millimeters earth cable, it's also the law, because the law says by one amovible transformer, it's the law to implement earth from 35 millimeters square in diameter. So, and of course, this is also not well represented, but I draw it as quick as possible, but just to show the main functions, so the main protection, what's really needed to protection from the cable, because this is not a switch. This is only, like I said, only to protect the cable, the cable. This cable from the earth is the law, so you have to connect all the way down to the mast and to the earth stripping from the cables, because the cables are going to be stripped, and they have also in their isolation earth in their stripping, so they have to be connected to earth before they go to the fuse. Anyway, I ain't going to calculate this. I'm going to say only say it's a 3 XPLA cable, and they are going to go underground, and you have to draw them. There's something. This is the worst case scenario, meter 20. Yeah, because you can go higher, and it depends on what you have above. But this is the worst case scenario, 1 meter 20. And you have to specify. You have to the signalizer here. The two signalizers. Yeah, you have to specify which kind of material you put on top of the cables, and the protection, of course, the protection, mechanical protection of the cables also. This is not the cables itself. This is the tubulation. It's a tube just to protect the cable, and this is you have also specified here. So in the connections, the connectors are these standard ones, standard connections for the medium voltage cable. Yeah. And okay, the power station we already discussed about. These cables are going to connect one earth cable. Yeah, this has to be measured. This has to be tested from the medium voltage side. It has to be tested, isolate as this isolation test, and the earth has to also be tested. Yeah, to 1 ohm, more likely. Yeah, you have to put the 3 bars down and do the 3 or 2. Depends which kind of earth tester you have. Yeah, this must be made. And in this project, I didn't implement the communication to communicate to the owner or to the power delivery company. I just put some meter here, or integrate some meter in the power station. The company is a German company, as I know. They make the power stations like the client wants. So you can implement the measurement, the connection measurements for the meter directly
into the into the into the power station, because you can implement the right after the connectors. Yeah? I mean right before the connectors. Yeah? You can implement there, right? You can implement in which case is supposed to be for the sensors to the meter, voltage sensors and 3 current sensors for the meter itself, and this can also be integrated there. So let's go to the DC side. So the AC side it's complicated. You have to measure a lot. You have to calculate a lot, and you have to make justifications and fill in the bureaucratic papers. Besides calculating everything and assume every responsibility of this. Now, let's go to the DC side. As we already saw before, you have the DC string combiner. You can combine the all strings together and connect it in serial. Raise to the voltage of 800 in 72. Calculated with a lot of error margin. I mean, if the temperature drops below certain level, the voltage rise higher, because the panels, like I said in previous video, the voltage panels are extremely efficient when the temperature dropped low and the sun always aiming at them right in the beginning and in the morning. Yeah, we don't know how how much voltage it will rise. I mean, I calculated this. The maximal voltage is 1000 volts. I put the 20%, almost 20% down, and I'll calculate it from the open loop. We can put 1 or 2 more panels in serial. I mean, one one would risk on also one, because in Portugal the temperature doesn't drop that much. Yeah, and we'll put one more. So and you can connect the strings with the string combiner that we already saw before. In this case, to 75 strings. Yeah, you can connect this because this 13.3 amps string, 872 volts, and you can connect. We need what I said before, five string combiners, 5 connected together to be connected to connect 74 strings in a total of 1125 amps minus 20%. So I calculated everything minus 20% because we never know. Another thing is, this is a bit let me say for me normal, because you have a pulse width modulation here that generates current and voltage to feed the transformer, and it goes out in AC with 3% of harmonic. That I don't like that. I don't like harmonics in the network. Anyway, this is so straightforward that you can connect even. I bet you can connect here some wind turbines. Yeah, wind turbines. The modern wind turbines work like that. They are not. They don't need to rotate synchronous anymore. They generate DC current, and later on they are converted to IC. through pulse width modulation. I bet we can connect a wind motor generating DC, and with some adjustments, this would like to work also, right? So I made this video uh, as practical and as simple as possible. We could go in with into academic discussions about what is the DC switching side of this that's isolated. It flows back. It and from the AC side, what is the overshoot? And like I said, what is the harmonics? Yeah, I mean, we can do everything. We can speak like over detailed, right? But this is only to show. This is not as complicated as it was for a few years ago, right? We can do this with confidence because you choose certificated products. Yeah, you have to rely, you have to buy and assemble the things, assuming that you have a certificated product and you can trust this product, right? You mostly don't have the time or the money to test these products, so you have to trust the certification. So if you trust the certification, there's ain't going to be much problems in that. Yeah? For people's life, okay, the engineers over there in Portugal, they have raised the insurance policies to cover more damage, but that ain't going to ensure people's life. That's why we trust, or we should trust, or we should use always uh, certificated products and do the proper calculations. If yeah, and that's the way it should be. Yeah, and that's it. I think it's enough for now.